No, I'm doing one tomorrow, and then my final is pushed back to Tuesday.
Okay.
So,
Okay. So we got another one scheduled. Okay. So what are we doing?
yep.
What do we got going?
All right. So I want to go over uh, um, properties of exponents first. Is the first thing.
Okay.
So first problem is parentheses, in the parentheses x cubed, and then in parentheses outside that, to the fourth power times x over 2x.
Like that?
Yep.
Okay. It's the very first thing you can do that's the simplest of all.
Um, isn't it do the exponents?
Well,
So
there's
like,
an even easier step there. Here. We got an x in the numerator and we got an x in the denominator, and they're both being multiplied. There's no addition being added to them.
uh,
So we can immediately cross those off.
okay.
Now, we have to worry about your rules of exponents. What's that equal to?
Um, isn't that just x, right?
We're talking about
Or
x to the third, all to the fourth power.
uh, uh,
Are you seeing my screen? Are you seeing what I have circled?
yeah.
Okay. So
So
what
wouldn't that just
rules of
be?
exponents apply when you do what I call double exponentiation?
Isn't it like subtraction?
No, it's multiplication. So it's x to
Okay.
the 12th. And the 2 is still in the denominator, so we leave it there. Let's cover these rules. Same base, x, different exponents. What do you do with the exponents? You're multiplying the bases.
XAB, right?
Tell me how to write this.
XAB, right?
XAB, like that?
Yeah.
No, it's not what you do. It's x to the a plus b power. In other words,
Okay.
when you are multiplying the same base in different exponents, a and b, you add the exponents. For example, 2 to the third times 2 to the fourth would be
2 to the seventh. Yeah, seventh.
always remember you're doing one step less with the exponents than you're doing to the bases. I'm multiplying the bases, I am adding the exponents. Think of it as one level less.
Okay.
Okay? Now, along the same line, here I'm dividing the same base, different exponents. What do I do to those exponents?
Uh,
One level less than division is what?
Addition or
One
multiplication.
level less than division.
Multiplication.
Subtraction.
I what?
Multiplication is the inverse of division. So all of these rules follow this principle of one level less. In other words, the
Oh,
first one we had x to the a times x to the b. Well, that's multiplication. One level less is addition.
Mm-hmm.
This one, we're doing subtraction. So it's A minus B. I'm sorry, this one that I circled, we're doing division. So it translates to subtraction, one level less than division. So if I had this, what's that equal to?
2 to the 4th.
Okay. What if I have this?
That'd be.
Nope, you can't do anything with it.
Oh yeah. Oh wait, why?
Why? Because it's different base.
Oh, okay.
These rules only apply when you have the same base.
Okay.
This is what I call double exponentiation. What are we going to do to those exponents?
So you do, it would just be XAB, right?
X to the AB. When you say XAB, that's what it means.
Oh,
X
okay.
times A times B. That's not what you're doing. You're replacing one exponent by multiplying them.
Mm-hmm.
In other words, you're multiplying those. Okay, so if I have 3 to the 5 all to the 7th power, what's that equal to?
Oh. That'd be 3 to the 35th, right?
3 to the 35th, yeah.
Okay.
So those are your 3 rules of exponents, and that's what they want you to apply in all of these problems. So give me some more problems.
Okay. So x to the 4th over 2x in parentheses to the 2nd times x cubed.
Like that?
Yep.
Don't really need the second set of parentheses, I guess. Now, you have a lot of choices on how to proceed when you have this, okay?
Oh.
You can do division first. You can do multiplication. But before you do multiplication, you got to do this exponentiation. So I would suggest we take care of that very first thing. So, not doing
that's
anything
2x.
for our numerator. What's 2x quantity squared?
2x squared?
What is that?
4x?
4x squared.
Well, wait, what? Oh yeah, because you have to distribute it out. Okay, I get it.
2x times 2x. You got to multiply the numbers. You got to multiply the variables.
Mm-hmm.
Okay, we still have this x cubed. Now, what I would do next would be to do this part of it right here. Was that?
Okay. That. So that's multiplication. So it'll be 4x to the 5th, right?
Yeah, good.
Okay.
Now, still got more to go because we still got division.
Mm-hmm. So then that would be wouldn't that just be 1 over 4x?
Very good.
Okay.
In other words, what it also was x to the minus 1 over 4. In other words, if I subtract the exponents, I get minus 1. But minus 1 merely means that it belongs in the other side of the fraction bar to the positive 1. So this becomes that.
Mm-hmm.
All right, what else?
All right. So x to the negative squared. So x negative squared over
X to the negative 2.
Over parentheses 2x to the negative 1. And then in parentheses squared times
Hold on.
x
What goes next?
times x cubed and then y to the 4th.
Like that?
Yep.
Okay. Now, the other thing about negative exponents is you can just move it to the other side of the fraction bar, no matter whether it's in the numerator or the denominator, and change its exponent to a positive number. Same exponent, but a positive number. So let's rewrite this so that we have all positive exponents for the moment.
Mm-hmm.
So what am I going to do with that x to the minus 2?
Move it down, right? So it'd be x squared.
Okay, and what am I going to do with this 2x to the minus 1?
Move it to the top, so it'd be 2x.
Don't need any exponent. 1 is assumed.
Oh, yeah.
Still got this x to the 3rd in the denominator and this y to the 4th in the denominator.
Okay. So, yeah, wait, what? Say that again?
Do you get how I got to that step?
Yes, yeah.
Okay. Now, let's go to the next step. What's the next thing we're going to do? Again, multiplication is easier to do than division. So let's do the multiplication in the bottom. We can multiply those two together. What do we get?
So that'd be x to the 5th and then y to the 4th.
Okay.
And then that would be 1 or... okay, so wait.
A 2.
2. Yeah, that's what I'm stuck on. So would I move that 2 down as well, or what?
No, the 2 doesn't go down.
It stays?
The 2 stays in the numerator.
So it would just be 2 over x to the 4th and then y to the 4th.
You got it. Just exactly like that. So the easiest way to handle these negative exponents is just to start right off and move them to the other side of the fraction bar. And it doesn't matter whether they're in the numerator or the denominator. You can do it.
Mm-hmm.
All right, what else?
Alright. That's it for properties of exponents. Now we're doing name each polynomial by degree and number of terms.
Okay, now that's a piece of cake. Let's do one of them. You'll get the idea.
M cubed minus 9 plus 8m squared.
What degree is that polynomial?
Cubic, right?
It's always the biggest one.
So, yeah, cubic, right?
Well, it's 3. The degree is 3.
Oh, okay.
Okay. And notice that it's being added to that. In other words, if that was multiplied, then I would have m to the 5th. So it would be a 5th degree polynomial. But as long as you're adding, you cannot add m squared to m cubed. Can't do it. You can multiply, you can divide, you can double exponentiate, but you cannot add or subtract.
Mm-hmm.
So give me the toughest one in that batch.
They only give me 2, and the other one's 2 minus 2n, so.
2 minus 2m?
Yeah.
What's the degree of that?
Just 2, right?
It's the exponent. It's not the
So
coefficient
just
of that.
1, right?
It's 1. That is a linear equation. In other words, whenever you have a polynomial that has a degree of 1, then you have a linear, meaning a straight line. If we were to graph that, it would be a straight line. Okay, what next? What other subject?
Okay, next subject is we're just simplifying expressions, so
Okay.
parentheses 1 minus 7p squared, and then plus parentheses 3 plus 5p squared.
Like that?
Yep.
Okay. When you have parentheses in an expression, usually you want to get rid of them. That's the goal. Can I get rid of the first set of parentheses without doing anything to the numbers? Or to the things inside the parentheses?
No, you cannot.
Why? Why can't I do this? It's the same thing.
Okay.
Now, can I do the same thing to the second set of parentheses?
Yes.
Yes. Because it's preceded by a plus sign, I can do this. If that plus 3 was a minus, you wouldn't be able to do it. Makes all the difference in the world. So in order to get rid of the parentheses, I just erased them. Now, you have 4 terms in a polynomial. Combine like terms.
Okay, so then it would be 12p to the 4th, right?
Hold on. You're not multiplying, remember. It's not going to be p to the 4th. You are not multiplying p squared times p squared anywhere here. You're adding them. Or subtracting, however you want to treat this negative 7p squared. Let's start with the numbers. What do the numbers come to? You're combining like terms. I mean, you can
it's
combine all
negative.
p squareds and you can combine all numbers.
So it'd be negative 2 p, right?
Negative 2p squared.
Squared.
Plus.
But wait, where do you get the squared from?
All right, hold on. P squared equals an apple. Okay? You got 5 apples right there. And you're subtracting 7 apples. So that gives you minus 2 apples. And an apple is a p squared. So when I combine minus 7p squared with plus 5p squared, I get minus 2p squared.
Okay, so you don't.
I'm just combining the coefficients. Minus 7 and plus 5 gives you minus 2. And they happen to both be the same thing so that I can add and subtract them. If one of these was a p cubed, I could not do that. But since they're both, it wouldn't be an apple, it'd be an orange if it was a p cubed. Okay? But p squareds are the same as other p squareds. So I can combine like terms. So I get minus 2p squared. Now if I combine the numbers, 1 plus 3 is 4. So that's your answer, and that's probably the correct way to write it, is to put your highest exponent variable first, your next highest one next, and finally your constant, the number only.
Okay.
Okay? Now, if I were to change, well, I'll wait until you get one. You're going to have one like that. Give me another one.
7, or parentheses 7 minus 3x minus parentheses 8 minus 2x.
Yeah, this is what I was looking for. Where that is subtraction. Okay? Now you cannot just remove the parentheses. Changes everything if you just remove the second set. You can remove the first set without doing anything. I can do that.
Mm-hmm.
But when I remove the second set, what does it leave me? Because I have to distribute that to both terms.
So that would just be negative 8x and positive 2x.
Correct.
So then it'd be
Like terms. All of those are x's.
it would be negative 9x plus 7.
Good. Okay. What else?
Alright. Here's one that looks decently hard. Parentheses 8x minus 5 plus 4x squared. It's all in the same parentheses. So 4x squared is in the parentheses. And then after plus 4x squared, new parentheses plus 3x squared minus 5x minus 8.
Again, first thing you want to do is try to remove all your parentheses. And the first set of parentheses is almost never needed.
Okay.
Unless that whole expression is being squared or something, then you never need that set of parentheses. So I can always get rid of it by just erasing it.
Mm-hmm.
And if the next set of parentheses is being added, I can just erase those also.
Okay.
If it's being subtracted, you got to be careful, as it was in the last one, because the subtraction sign would need to be distributed to all terms inside the parentheses. But when you're adding, you can just get rid of them. Now combine all like terms, starting with the highest degree term.
Alright, so it'd be 3x, and then...
Hold on, what's the highest degree term?
8.
No, the highest degree means the highest exponent.
So 2.
Okay, so combine all of those.
Alright, so it'd be 7x squared.
That gets rid of that one and that one. Now what?
Plus 3.
X gets rid
X,
of that
yeah,
one
sorry.
and that one.
And then it'd be negative 13.
Yeah. And the reason I said start with the highest is because when you write polynomials, they want you to write the highest degree first, the next highest second, and the constant last.
Okay.
Okay?
Alright, those look... So I'm not gonna do those. And then, alright, I'm just gonna do one more of these then. Alright, so parentheses 2b squared plus 7b cubed minus 3b, all in the same parentheses. And then minus parentheses 7b squared minus 3 plus 7b cubed.
Yeah, now they don't always give it to you in proper format. They did not here. In other words, they got the b cubed in the middle. That's okay, you can handle that. But when you give a final answer back, you want to put it in order.
Okay.
Okay? So, what's the first step?
Remove parentheses.
Which ones?
Both.
Well,
Or no, just the first ones, because you have to
okay.
distribute
You can
the
do that without doing anything.
Right.
So, to remove the second one, tell me what I should write.
Alright, it would be, so net minus 7b squared plus 3 minus 7b cubed.
Good. Now, start with the highest degree polynomial and combine all of them.
Alright, so just be b cubed. Negative b cubed, right? Or
I got a plus 7 and a minus 7.
that would just be nothing, right?
Exactly.
Okay.
There are no more b cubes in this thing. Now go to the squareds.
So it'd be 5b squared.
No.
And wait, what? Yes, negative 5b squared. Sorry.
Okay. Makes a big difference. You get it completely wrong if you put 5b squared. You don't even get a point. Okay. So that gets rid of that one, and that gets that one. Now how about the b's?
Negative 3b plus 3.
Okay. All right. What next, Blake?
Alright. Alright. Next one is we're factoring by grouping.
Okay.
So 30m cubed plus 36m squared minus 5m minus 6.
Seriously?
Yeah.
This was 30m.
Or wait. The first one is 30m, yeah. And then plus 36m squared.
How did I know that? You didn't say it.
Well, I don't know, but yeah, it's 30m.
The reason I knew it is because grouping only works if the ratio of that coefficient to that coefficient is identical to the ratio of that coefficient to that coefficient. So we would have 30 over 36 has to be equal to minus 5 over minus 6, is it?
Yes.
Yeah, it is. So, that's your first test. If that is true, then you can solve it by grouping. And that has to be true to be able to solve it by grouping. If it is not true, you cannot solve it by grouping.
Okay.
And first of all, solving cubics, you're not going to believe how hard it is. Unless you can do it by grouping. And then it's just medium hard. Still hard, but it's not as hard as if you can't do it by grouping. Then it becomes like a 20-minute problem. Serious. There is no cubic formula like there is a quadratic formula. In other words, you can't just take any cubic and solve for its zeros by plugging it into a formula. It doesn't work that way with cubics or anything higher. But there is a very, very, very tiny percentage of cubic equations that fit this mold. where those coefficient ratios of the first two terms are the same as the second two terms. And if that is true, then we can group them. And the way we group them is I'm going to put parentheses around them instead of removing them. I can put parentheses around the first two terms without changing anything. But I can't just add parentheses around the second two terms because it actually changes the expression. In other words, I still want a minus, and that still has to be 5m, but what does this have to be? Minus or plus 6?
Plus.
Yeah. In other words, what our goal is to not change this expression. So all we're doing is rewriting it. Much like if we had to take the bottom row and remove the parentheses, we would have to change that to a minus 6, right? So when we are adding parentheses, we have to make sure that it equals the original statement. Now that we have parentheses around it, start thinking greatest common factor. What's the greatest common factor amongst that expression?
2?
No, you can actually divide 30 by 6, and you can divide 36 by 6.
Oh, yeah, 6.
I can definitely pull out a 6. How many variables? There's some variables I can factor out also.
M squared, right?
M squared, exactly. What's that leave behind?
Just
After I factored that out. Well, it's 5m.
5m, and then just a 6.
Plus 6.
Yeah.
Not just a 6. You've got to have that plus sign. When you're dealing with polynomials, the plus sign is not assumed. If I write 5m and then 6, that's 5m times 6. So if I'm adding 6, I got to use a plus sign. Okay, now notice that there's no greatest common factor over here. So it's still that. Now, it's this part that's tricky for most students, because you have spent your whole life finding greatest common factors to be single terms, like 6m squared. Not with this problem. The greatest common factor between those two terms is 5m plus 6. See why? 5m plus 6 divides into both terms. Leaving what?
What?
Leaving what? You're factoring out that.
So just nothing, right?
Well, I've got this for sure. So 6m squared. And there's a hidden 1 right there. Minus 1.
Okay.
So we've factored it.
So
that's the answer. 6m or 5m plus 6 in parentheses, excuse me, times in parentheses 6m squared minus 1.
Okay. So can you explain the factoring again?
Yeah, if this was equal to 0, if it was an equation, well, now that thing is equal to 0, and I can solve it because I can set 5m plus 6 equal to 0, and I can set 6m squared minus 1 equal to 0. So I can come up with actually 3 solutions. But they didn't really give it to you as an equation. They gave it to you as an expression, like that, and they just said factor it. So do everything exactly the same, except we don't have an equal sign or anything on the other side of the equal sign.
Okay.
And this is kind of an odd problem for them to give you, because this can actually be factored a little bit more, but they haven't really taught you to do that yet. They've taught you difference of perfect squares, and that's not the difference of perfect squares. So we really can't take it another step. You can, but they haven't taught you that yet. So I presume the answer they're looking for is that one right there on the bottom row there. 5m plus 6 times 6m squared minus 1.
Okay.
Notice the difference in normal factoring. Normal factoring, I pull out a greatest common factor that's a single term. This kind of factoring, I factored out a binomial term. In other words, two terms that are being added or sometimes subtracted. All different concept. But it's legitimate mathematics. Okay, what else you got?
All right. 8b cubed minus 64b squared minus 5b plus 40.
Okay. First test is, can this be factored by grouping?
Yeah.
Why?
Because 8 and 64 is 1.
Here's why. 8 divided by minus 64, in other words, that ratio, is the same as minus 5 divided by plus 40. Both of them are minus 1/8. As long as this is true, then you can solve it by grouping, always. And since that's the only method they taught you, at this stage, you don't even need to check. If they're giving you one and say solve it by grouping, you know that ratio is the same. So rewrite this with parentheses.
Okay, so
That's always the first step in grouping. You have to put the parentheses back in.
okay, so wouldn't it just be like, you want me to factor something out, or?
No, I want you to separate it by groups. That's why it's called grouping. You're going to separate it by two groups. You're going to put the b cubed and the b squared together in a parentheses, and then you're going to put the b and the number together in a parentheses.
Okay. So, it would just be 8b cubed minus 64b squared, and then in parentheses minus parentheses 5b plus 40.
No, you can't just add the parentheses when there's a subtraction sign like that.
5b minus 40, right?
Okay. And the way to check is to remove the parentheses and see if you get the same thing. In other words, the whole goal is to not change the expression, just to write it differently.
Okay.
Okay, now look at each set of parentheses and factor out the greatest common factor.
All right, so it would be 8b squared, and then parentheses b minus 8, negative 5, parentheses b minus 8.
Okay, now what?
You would...
What's the greatest common factor that you're going to find in that expression?
b minus 8?
Yes.
Okay.
That's what we're going to divide both parts of this expression by. What's left over?
8b squared minus 5.
There you go. Now you got it. And I'm just going to tell you, this is the answer they're looking for, but I could also write it, I could factor this second one. It's not difference of perfect squares, but surprise, surprise, you don't need difference of perfect squares. They just have to be difference. Even though all these years they've taught you that it has to be difference of perfect squares, it does not have to be perfect squares. So that's the final answer. If you were factoring it all the way down, that's what you'd get.
Okay.
In other words, I treat that as a perfect square, so all I'm going to do is take the square root of it, which is square root of 8 times b. Same with the 5. But they haven't taught you to do this part here, so I'm sure they're looking for that as your answer. All right. What else?
All right. So now we're just gonna do graphing quadratics.
Okay.
All right. So y equals x squared plus 6x plus 13.
There's lots of ways to graph quadratics. I can think of at least 3. First of all, notice that that does not factor nicely. Factors of 13 are 13 and 1. There's no way you're producing a middle term of 6x. Okay? If it did factor, then we would be putting it into x-intercept mode, and then that's easier to graph. So if it did factor, I would factor it. You got all these modes up here. Let me write them. This is Vertex Format. That's the most popular one. This is X-intercept format. Not quite as popular, but very useful. Because if you know where the X-intercepts are, you can figure out where the vertex is pretty easily. And this is standard mode, standard format. That's what they usually give it to you in. That's what this one's in. Now, to graph it, I could do 2 things. I could try to put it into that mode by factoring it, but as I've said, we've already looked at it and we can't factor it, so that's not a good idea. I could put it into this mode up here, but I would have to complete the square. And that's hard to do also. The easiest thing to do when you get it in standard format is what? What is the x-coordinate of the vertex going to be equal to?
I haven't done this for so long.
Think the first half of the quadratic formula.
So negative b plus minus.
No, just the first half, top and bottom.
Okay, and then
Negative b over 2a.
2a, yeah.
That's the x-coordinate. So let's figure out, that's a good starting spot. Let's figure out where that is. What is that?
It would be negative 6 over 2 parentheses, so negative 6 over 1.
Negative 6 over 2, which is minus, minus 3. Okay, now the next thing we need to know is the y-coordinate of the vertex. How do we get that? There's a formula for it, but you don't need to memorize that. It's much easier to just, since we've solved for the x-coordinate, how can we get the y-coordinate?
You just plug it back in.
Yeah.
So it'd be.
So that gives you 9 minus 18, which is minus 9, plus 13, which is plus 4. So now you have a lot. When you have the vertex, you have almost everything. There is minus 3 plus 4. Is this quadratic open up or down?
It opens up.
Correct. And all quadratics are parabolas. Okay? Now, I need two other points. I can't graph a parabola with just the vertex. But if I can get any other 2 points, that defines a parabola. Now, I've heard some teachers, sometimes they want 5 points, which is ridiculous. 3 points define a quadratic and a parabola. So is all we need is 2 other points. Now, usually the x-intercepts are the 2 points you want to find. But notice that that's going to involve using the quadratic formula, because x-intercepts are where y equals 0. If I set that y equal to 0, I got to use the quadratic formula to solve it, to get those 2 points. There's 2 other points that are actually easier to get. Let's look at the y-intercept. What is that value right there?
Well, that'd be 13, right? Or
yeah, that's the y, and the x value is 0. Right? In other words, by definition, y-intercepts have an x value of 0. Okay? So we got 1 point right there. Now, there's a thing about parabolas that they're symmetrical. So it's relatively easy to figure out that point. What's the y value of that point?
So it'd be 13.
Hold on. That's the
y value.
Negative
6, 13.
Very good. In other words, we know that there is a invisible line of symmetry that goes through there, and that this distance from here to here has to be the same as the distance from there to there, because they're symmetrical. So you knew that you were 3 units away from the right point, so you got to go 3 units away to the left. And you now have 3 points. That's all you need. You got that one, that one, that one. As long as they're defined like we've done here, that's all you need. And if you graph it without those second and third points, you can't tell the difference, because some parabolas might go through that same vertex, but they would be skinnier. They wouldn't have the same y and the other 2 points. Some parabolas might go through that same vertex and be a lot fatter, like that. So that's why you need 3 points to define or to graph, because otherwise you don't know how to fat or skinny to make it, even though you start off with the vertex. Okay, what else? Another one of those, maybe.
Okay. Y equals negative x squared plus 2x plus 1.
What are we going to do here?
So would be negative 2 over.
Okay, so we're going to use the minus b over 2a to come up with the x coordinate. So it's negative 2 over what?
Over negative 2.
So that's plus 1. Now tell me what the y coordinate is of the vertex.
Just 1. Oh, no. It would be 4. And then.
Plug in 1 for x.
Yeah, so negative 1 squared is 1 plus
Hold on.
2 is.
Hold on. There's not parentheses around that negative sign. In other words, this 2 right there applies only to the x.
Okay.
So
Wait.
if I'm plugging in, then it's negative 1 squared, like that.
Okay.
Plus 2 times 1 plus 1. Now, do the exponent first. 1 squared is 1. And then apply the negative sign. So what we really have is minus 1 plus 2 plus 1. Which is 2. Okay. Here's what I need you to understand. That is not the same as this. On the right, the negative sign is being squared. So this becomes positive x squared. But on the left, the only thing that's being squared is the x. So that stays at minus x squared. That's why they're not equal to one another. All right. Now, still not done because it's all we've got is the vertex. Vertex is at 1, 2. Does this open up or down?
Oh, I'm down.
Find 2 other points.
So 1 would just be 0, 1. Another one would just be 2, 1.
Good. That's fast. You did that really fast. That's all you need to do to graph these things is find 3 points and draw a parabola through them. Okay. And that's relatively easy coming up with the x and the y coordinate of the vertex. And as long as it goes through the y-axis, then you can always get the y-intercept pretty easily also. Yes, it always does go through the y-axis. There's no way to draw a parabola without it crossing the y-axis. So this method here actually works quite nicely. What it doesn't always do is cross the x-axis. I can have a parabola like that. And if you tried to solve for the x-intercepts, you'd get imaginary numbers. But there's no way to draw a parabola where it doesn't go through the y-axis, at least not a vertical parabola. There's horizontal parabolas that are part of conic sections where you could do it, but not a vertical parabola. Either has to go up or has to go down, and which means it always crosses the y-axis. What else? We got time for one more.
Okay. So y equals parentheses x minus 3 squared, and then plus 2.
What format's that in?
Isn't that vertex, right? Vertex
Yeah, which is kind of nice. That means they tell us the vertex in the equation. What's the vertex?
The vertex is it's 3 and 2, right?
Very good. Positive 3, positive 2. Does that open up or down?
Up.
Give me two other points.
So.
Now notice that because it's in vertex format, it's not so easy to get the y-intercept. But it's not hard. What's the x value when you're looking for the y-intercept?
0. So just
plug in 0 for x, and you can get this y-intercept right here.
-3 squared is 9. Plus 2 is...
It's what? It's -3 squared.
9.
Plus 2?
11.
Okay. And now there's a point right over here, symmetrical.
Then it would be 6 at 11.
There you go. That's how you do it. And it would have been next to impossible to find the x-intercepts because they don't exist. We would get imaginary numbers which wouldn't help with the graphing at all in terms of showing us how skinny or fat that parabola is. So finding the y-intercept is probably the easiest way to find your other 2 points always. And the problem is that when they give it to you in vertex format, requires a little bit of math. You have to plug in 0 for x and figure out what you get, as opposed to when they give it to you in standard format, where the last number is the y-intercept. It's real easy when they give it to you in standard format, but of course, figuring out the vertex is a little harder. So, favorite format is probably vertex format, because you get started immediately with your vertex, and then finding the other 2 points is relatively easy also. All right, Blake, I will let you go for tonight.
Thank you very much.
Sounds like we got one more session, so I will talk to you tomorrow.
All right, bye.
Bye-bye.